This PowerPoint is going to go over how to solve one-step equations using addition and subtraction. So this is a review PowerPoint of what we've gone over earlier in the week, earlier in the chapter. So we have some notes on this already, but what I want you to do is open up your notebook and title the next available page what you see on the screen here. So go ahead and pause this video until everyone has their title written on their next available page. Now, before we jump right into solving one-step equations, we are going to start with checking to see if a given value is a solution to a given equation. So our first example here, which I'd like you to write down in your notebook, is x plus 42 equals 85. And the value that we're going to check to see if it is a solution is x equals 43. So go ahead and pause this video, write this in your notebook, and then we will check to see if this is a solution. So because we're given the value x equals 43, we're going to rewrite this problem here and plug in 43 for our x. So underneath our problem, I'm going to write 43 plus 42 equals 85. So what we are checking here is to see, does the left side and the right side equal the same number? So we're going to find the sum of 43 and 42, and when we add that together, we get 85. We have equals 85, and since these are equal, 85 does equal 85, yes, x equals 43 is a solution to this equation. So we're going to try a couple more just like this. So our next example, same directions, but a different problem, is 19 minus g equals 7 when g is equal to 5. So again, I want you to write down this equation, and then what we're going to do is rewrite the whole equation with the given value for g plugged in. So we're going to write 19 minus g equals 7 in our notebooks. And then we're going to rewrite right underneath it, 19 minus 5 equals 7. And we're going to now find the difference of 19 and 5 on the left side of our equation. And when we do that, we take 5 away from 19. We should get 14 equals 7, which we should know is not true. So we're going to put a slash through the equal sign, which means not equal to. So I could leave my answer like this, or I can write no. But either way, g equaling 5 is not a solution to this equation. We have one more example until we get into solving one-step equations with addition and subtraction. So I want you guys to try this on your own first. It's m over 4. Remember what that division bar means, or excuse me, that fraction bar means division. So m divided by 4, or m over 4, equals 16. And we're going to check to see if m equaling 4 is a solution. So go ahead and pause this video, try this one on your own, and then you'll check it with me. So I'm going to rewrite this problem. 4 over 4 equals 16. So here this division bar, this fraction right there, means 4 divided by 4. So 4 divided by 4 is 1. 1 equals 16. That is not true. So again, that is a no. So those are the examples to check to see if a given value is a solution. Now we're going to move on to solving one-step equations using addition and subtraction. So our first example says to solve the equation and check your solution. So again, since that is in our directions, we must have a check step. So we're going to look at our equation y minus 7 equals 3. I'd like you to copy that down, and remember that even though some of these you will be able to do in your head, you do need to show your work. So my first step, I'm going to draw my railroad tracks, and I'm going to look at this original problem on the left side here, y minus 7. And I'm going to say, okay, well that is a division, or that's a subtraction problem. So in order to undo subtraction, we need to use addition. So this is the inverse operation. We're going to add some value to both sides. So in order to get y by itself, all alone, on the left side of this equal sign, or what other people call isolating the variable, we're going to add 7, but we have to add it to both sides. So that minus 7 plus 7, negative 7, positive 7, those go away, they cancel out. We're left with just y on the left side. Drop down our equal sign, and we have 3 plus 7, which gives us 10. So right now we say y equals 10, but since we need to check our solution, we have to add a check step. Since we believe that y equals 10, we're going to plug that in back to our original problem. So basically this is like checking to see if this is a solution, like we were doing earlier. So 10 minus 7 equals 3. The difference of 10 and 7 is 3. 3 does equal 3, so we know we're correct. Y equals 10 for this equation. The next problem, p plus 5 equals 8. Again, I'm going to start with my railroad tracks to separate the left and right side of my equation. I'm going to see that this is an addition problem, and I'm going to use the inverse operation, or the opposite, to undo this addition. We're going to subtract, but we have to subtract from both sides. So this is the step that I need to see. In order to get p all by itself, I need to subtract this positive 5 to make that 0. So I subtract 5 from both sides. So those 5's on the left cancel out. I'm left with just p on the left. Drop down the equal sign. 8 minus 5 gives me 3. Again, I'm going to do a check step. Plug this 3 back into the original problem. We say that 3 plus 5 equals 8. The sum of 3 and 5 is 8. 8 equals 8. We know we're right, so we can box the answer p equals 3. So any problem that we are solving, one-step equations, we need to have all of this work on every problem. Even if you can do some of this stuff in your head, you need to show me the subtracting on both sides, or the addition on both sides, like we did on the problem right before this. So let's try this last one. 25 equals q plus 14. I'd like you to copy this down in your notebook, pause the video, and try this one on your own. So I've already added my railroad tracks, and I want to get q by itself. Even though this problem's written a little bit different, the answer, or the sum, is actually on the left side instead of the right side of the equation, we still do the same process. So I want q alone, and this is an addition problem, so I'm going to use subtraction, and I'm going to subtract 14 from both sides. Those 14's on the right side here cancel out. I'm left with q. Drop down my equal sign, and I'm going to do 25 minus 14, which gives me 11. Again, I need to check my solution. So I'm going to go back to my original problem. 25 equals, we say q is 11, so we're going to plug in 11 for q, plus 14. We have 25 equals. We need to find the sum of 11 and 14, which is indeed 25. So we know that we are correct, and we can move on. If things are moving a little too quickly, feel free to pause the video, go back a little bit, rewatch any section that you need, but make sure you are doing exactly what I'm doing on the board here. Copy down the exact same work, make sure you understand why we're doing what we're doing, what operations we're using, what inverse operation we should use, and make sure you are always checking your solution. So we've done checking if a value is a solution to an equation. We've also solved a few equations. Now what we're going to do is actually look at some word problems. These can be a little bit trickier, because we usually have to set up an equation. So our first word problem says you get in an elevator and go down 8 floors. You exit on the 16th floor. Write and solve an equation to find what floor you got on the elevator. What I'd like you to do is pause this video and copy down this word problem. These are really good examples to have in your notebook. So take your time, write down the 2 sentences, and then we're going to go through how to set up an equation, and then we're going to practice solving it again. So when dealing with word problems, I usually go back, I read it one time, and then I go back, read it again, and underline important information. So the first sentence says, you get in an elevator and go down 8 floors. And if we think going down 8 floors, hopefully we think, okay, that's probably subtraction. It says you exit on the 16th floor. So this is kind of our answer. This is our end answer. It says write and solve an equation to find what floor you got on the elevator. So already the question tells us that we don't know what floor we got on. So that's going to be our variable. So I'm going to put x equals floor we got on elevator. And go ahead and write this down with me in your notebook. Make sure you have everything that I have written down as well. So the X is going to stand for what floor we actually got on the elevator. So we don't know that floor, but we do know that whatever floor we did get on the elevator, we went down 8 floors. So we're going to subtract 8 from whatever floor we got on. And we know that we exited on the 16th floor. So we ended up on the 16th floor. So X minus 8 equals 16. That minus 8 standing for going down 8 floors, and this 16 standing for what floor we ended up on once we got off the elevator. So with this equation, now we're going to solve it and figure out what floor we actually got on the elevator. So this is a subtraction problem, so we're going to use addition to solve for our variable. We're going to get x all alone, so we added 8 to both sides. On the left, those 8's cancel out. We're left with just x. We're going to bring down our equal sign here, and we're going to find the sum of 16 plus 8, which is 24. So here, now we have to make sure we use the context of the problem. Remember, a word problem always needs a word answer. You need a label. So this x equals 24 means the 24th floor. That is the floor we actually got on the elevator before we went down 8 floors. And that's how you do our first word problem. We have one more word problem, and this one is about penguins. So we have an emperor penguin is 45 inches tall. It is 24 inches taller than a rockhopper penguin. Well, this is what and solve. This should say write and solve an equation to find the height of a rockhopper penguin. Okay, went back and fixed that. So it's write and solve an equation to find the height of a rockhopper penguin. So again, go ahead and pause this video, copy down this word problem, and then if you feel confident, go ahead and try and write an equation before we go over it as a class. So pause this video, copy down the problem. Again, if you feel confident enough, try and write a problem, an equation, to see if it matches what we end up doing. So again, I'm going to go back, reread this problem, and underline or circle, highlight the important pieces of this word problem. So we know that the emperor penguin is 45 inches tall. We also know that that 45 inches, however tall that penguin is 24 inches taller than a rockhopper penguin. So if we think taller than, that's greater than or bigger than, so we should think of that as an addition problem. So we're going to write and solve an equation. So this emperor penguin is 45 inches tall. And we know that that is, remember is means equals in math, 24 inches taller than the rockhopper penguin. So I'm going to put R, and then over to the side I'm going to put R equals rockhopper. So we are clear on what our variable means. So now we have the equation 45 equals 24 plus R. And this is going to help us find the height of a rockhopper penguin. Go ahead and pause this video. Try to attempt to solve this one-step equation on your own, and then we'll go through it together. Okay, so if we are going to solve this problem, I'm going to draw my railroad tracks. I'm going to find what operations being done in the original problem. Here it's addition, so I'm going to use subtraction to isolate my variable or get it all on its own. In order to get R by itself, I need to subtract 24 from both sides. So those 24 on the right cancel out. I'm left with just R. Drop down my equal sign, and I have to find the difference of 45 and 24. So when I subtract 24 from 45, I should end up with 21 equals R. And what that means is the rockhopper penguin is 21 inches tall. 21 inches tall. Which makes sense if we think that the emperor penguin is taller than the rockhopper penguin, so that rockhopper penguin should be shorter than the emperor penguin's height. So make sure when you have word problems, you're underlining, highlighting keywords, trying to identify what operation is being used, and set up an equation that makes sense. So once you get your answer, think about the answer and make sure it makes sense. Hopefully this video has been helpful to review. If you need to re-watch any part of it, feel free. But go ahead and get started on some practice problems and practice the skill until you are a pro.